Hey there again. Today we have a guest from all the way from Moscow, Dmitry Soshnikov. We're going to hear his presentation, Science Art in the Cloud, and how Dmitry built a museum exhibition. So, Dmitry, how are you?
I'm great. Thank you so much. And thank you for having me here.
Okay, so can we start your presentation?
Yes, definitely. So when I heard the name of the conference, Build Stuff, I thought that I should probably talk about how I built something. And that's how the idea of the talk came about. And I will tell you today, essentially, how I built an exhibit for one of the museums in Moscow. And because it's not something I do professionally. Professionally, I am cloud developer advocate. So I work for Microsoft. And I try to get people excited about technology. That's what I do. So I also write like blogs and Microsoft Learn modules and collect product feedback. So if you think that Microsoft Cloud is not the best, you know whom to contact, you should let me know. I also teach in a few universities in Moscow, and I used to do some AI and ML software development at Microsoft as well. So the building the exhibit is kind of in between my work and hobby. It's work because it is something very exciting when you when you show people how a neural network can draw a picture, how you can produce the pictures like that using technology. People get excited and you can talk to them about technology. I also have a daughter who goes to art school and she goes to math school, so she's also in between science and art, and sometimes we do some things together. So that's why I'm interested in this intersection of science and art. And one of the ideas that I have is called people blending, and I will tell you about the exhibit which I built based on this idea. So the idea is the following. If you take a lot of pictures of people and align them in such a way that eyes and some other facial landmarks are exactly in the same position, then if you can combine all those pictures together, you get this kind of blended portrait of a person, which looks nice, I think. And you can do it like with pictures of different people. You can combine two different people, like in this example, me and my daughter, and it looks somewhere in between. Or you can combine faces of one person or different ages, or do some other crazy things with that. So the idea is that, first of all, you need something to extract facial landmarks, the points in the face, the points of interest. And this can be done, this is of course can be done with a neural network. It can also be done with traditional computer vision techniques, but less accurately. So normally you would nowadays use neural network for that. And also there is a cognitive service in the cloud which can do that, called Face API from Microsoft. And it's very easy to use. You just do one function call to the cloud, and it gives you back all the information about the picture. And then once you get the points, you need to do a so-called affine transformation. Affine transformation is when you like rotate, scale, and move the picture to the correct position. So essentially what we need to like move, rotate, and fit the picture so that eyes occupy exactly the same points. And this can be done pretty easily with Opencv. Opencv is like the something which comes to mind when talking about image processing. So that is also a pretty simple operation. I will show you first how cognitive services work, and you can try that yourself as well. If you go to microsoft.com/cognitive, you can see at the web page there are different services related to language processing, to speech, and to vision. And we'll go to vision, and I will show you computer vision, like the first one which comes to mind. And here at the web page, you can actually see what the service sees when you give it a picture. So, for example, in this picture of three ladies, you can see that it can detect the notebook, it can detect people. And on the right, you have the JSON file which a programmer would get. So it even contains the description of the picture in real language, in English language. And you can upload also your own picture, like I will try with one of the pictures of myself, and if you can see, it even it knows my name. Like it says Dmitry Soshnikov holding a sign, because Microsoft services can recognize my face, and it can determine age, gender, and like facial length, like rectangle, and so on. So that's what we will be using to create this kind of blended portrait. If you want to like see for yourself at a slower pace how this can be done, there is a GitHub repository, this one, where you can go, and it contains Python code for creating cognitive portrait. Let me actually show you how this looks like. There are a number of Python Jupyter notebooks which contain different techniques, like because you don't always combine just faces by blending them together. Sometimes you want to achieve some more interesting effect, like for example like this one. When you have two faces side by side, you can, for example, combine a younger and older version of the same person, or you can have something like this one. And all that is achieved by different pieces of Python code, and each technique is represented by its own notebook. So what you need to do if you want to create your own portrait, you just need to run this like one of those notebooks. The one that contains most instructions is called Cognitive Portrait IPNB. So if you want to run it, you have several options. Like if you have the access, if you know there is a technology called GitHub Codespaces, it's extremely cool because it allows you to say right from here that I want to open this repository with a code space. You say I want to either create a new code space or use existing one. You click here, and you are presented by a Visual Studio Code essentially environment which runs in your browser. So you can easily start editing project right here inside the browser. Or if you prefer more like slightly more comfortable version, you can go here and say I want to open this in Visual Studio Code, in which case you will be switched to your own Visual Studio Code running on your computer. So how this drawing a portrait looks like. I have in this repository sample images of Bill Gates. They are in the images Gates directory, a number of pictures of Bill Gates. Let's try to combine them. So first thing we do, we install some Python packages, including the one for cognitive services. Then what you need to do, you need to have a key for accessing cognitive service, because like nothing comes for free. You need a key, and you can get the trial key here. There is a link right here in the notebook. If you click here, log in with your Microsoft account, and you will get the key and the endpoint for the service, which would be good for 7 days. So that would be enough for you to experiment with this. If you want like to use it for longer time, you can create free Azure subscription, or if you already have Azure subscription, then that's even better. With the free subscription, you would have this service available for you for free in certain limited amount of calls for a year. So that's quite a lot of time. So once you have the key and the endpoint, you put them here. And the way you use the service is pretty simple. You import some, create the instance of face client, and then you just do one call. You say, here is, for example, the URL of the picture that I want to process. And this is actually, a photograph. I can open it and see that it's actually a photograph like this. So then I can just say detect with URL, and I end up with the dictionary of coordinates of important facial landmarks. That's exactly what I need. I can also say, instead of return facial landmarks, I can say return face attributes, and then give it age, and it will give me back the age as well. I can actually remove facial landmarks probably, just not to crowd everything, and it will give me the age, face attributes as dict. And you can see that sorry, the age is 41. So it's pretty easy to use this kind of services. So then we need to process all images. I specify the path here, images gates. And here is the example of the first image from this directory, and the facial landmarks overlaid on top of the picture. You can see those red dots. It's probably not very nicely visible. Let me try with another picture. also not very visible. So this is just to show that cognitive services work pretty well. Yeah, you can see the dots correspond to like important facial landmarks. Then what you do, you process all pictures inside the directory, and the pictures look like that. I can display them here. Those are, we'll see in a moment, original pictures which I'm using. And then I can apply affine transformations for to them. I compute the coordinates of middle of the mouth, because to compute the affine transformation, I need transformation of 3 points. So I would say I want to move eyes to specified locations, and I also want to move some third point somewhere. And for that, I would use middle of the mouth. I will compute that middle of the mouth and compute the affine transformation applied to the picture with just 2 function calls. So here you would see the images aligned in such a way that head is exactly in the same position. So now if we superimpose all those images together, we will end up, here I show how to superimpose 2 images. And then if we superimpose all of them, it looks something like this. This is the portrait of Bill Gates created in such a way. So if you want to practice this yourself, you can grab the code, or tomorrow I will have the masterclass in the morning in which I will describe pretty much the same technique in a little bit more detail. So you would, if you want to view the same presentation at a much slower pace and ask questions, that would be a good time to do that. And you can bring in your pictures and come back with your own portrait like this. That is the technique itself. And if you want to create something based on this idea, you are more than welcome to. In this repository, there are a few notebooks contributed by some other people. Some of them my students. I ask students sometimes to practice and create some interesting techniques to lay out pictures based on the facial landmarks. So now, about the exhibition. So at some point, one of the museums in Moscow, it made a call for content. It called all digital artists and said, like, do you have some interesting thing to contribute? We are opening the exhibition for everyone. And I thought immediately, how can I convert this idea of cognitive portrait into something presentable in a museum in the interactive way? And the idea was the following: like we can create a device which takes pictures of all people passing nearby, and then it creates the blended portrait of a visitor of an exhibition. So that's exactly what we did. The first prototype you can see here. We are experimenting with my daughter. It takes pictures like every few seconds. And first of all, it takes pictures of me, and then it starts taking pictures of my daughter. So you see how it blends together like 10 or 15 last pictures. So you can see that how the face changes from one to the other. I think this looks pretty cool. In the real life, of course, it will look a little bit differently because it will take only a couple of pictures of each visitor, and it would create some kind of this blended portrait. So how can we do that? To do that, the best architecture I came up with is to use some kind of client application, which would be a UWP application, Universal Windows Platform, which allows me to use either a normal computer or Raspberry Pi. Raspberry Pi can run Windows 10. And this application would look for a face. The very good thing is that Windows 10 contains built-in recognition for faces. It can detect face. It does not detect the landmarks, but it detects the presence of a face in front of the camera. And that is important because I do not want to spend a lot of money on trying to recognize the face on the picture which does not contain a face, because each call to a cognitive services, it costs a little bit for non-trial version. So that's why it's very good, because Windows 10 contains this recognition out of the box. And then once face is found, we do a little bit of delay to make sure that the face is stable in front of the camera, and then we send this picture to the cloud. In the cloud, I use a technology called Azure Function, which is essentially a piece of code which reacts to some external event. In my case, it's HTTP request. So I send the picture there. It stores the picture in the blob storage and returns me back the combined picture of several previous ones. And I display this combined picture in my exhibit. So that's the architecture. And the good thing about this architecture is that I can then put the same exhibit, like not the same, but essentially the same hardware into different exhibition, and it would take pictures of different visitors and blend them together as well. So this allows us to kind of go through space and create the blended portrait across different geographies and also across time, because we can blend pictures from yesterday and we can combine them in very different ways. So I will show you now how to build this. The first part is UWP application. So that's how it looked like. I will show you how it runs from Visual Studio. So I will first start it so that you get the impression of how it looks. Right now, it's not complete application. It just does the first part. It takes a picture. So you see there is this countdown timer. So when the person gets in front of the camera, it does the countdown 3 to 1. And then when it's 0, it takes a picture. And it shows the picture below here in the interface. So that's the current functionality. And on the right, there is a placeholder where I would insert the image when it's produced. So let me show you the source code a little bit. So the good thing here is that, as I mentioned, we can recognize faces automatically. I can detect objects like face detector. And this face detector would essentially call back my function whenever a face is encountered. So this is done. So this is the long initialization code. And when face is detected, it calls face detected event. And what I do when face is detected, I start the countdown timer. Countdown timer 3 to 1. So every second it calls my function called counter callback, which updates the number inside the UI. And when counter reaches 0, it like captures the picture into memory stream. It cuts out the face so it shows it in the interface below. And then there is commented out code which needs to run in order to call the service and return back the picture. So with that we will add in later on. And then once I get this, I'm pretty much done. I can wait for the next person. So that's pretty easy. I would not go into much detail here. Of course, there is a very beautiful, well, not very beautiful, but some layout, design layout, and some binding. So, for example, as soon as I insert the new face into the collection, it automatically updates the interface so that those nice features are provided by UWP platform. Yeah. So now the main part is creating the Azure function. Azure function we would create in Python because we need to do image manipulation. Python is the best language for that. You have the link here on the documentation on how to do that. But essentially, the easiest way is to install local tooling and create the function locally, debug it locally, and then deploy to the cloud. So the Azure function is a very beautiful thing. Azure function is called serverless because it allows you to create a piece of code which will just run when you need it. You don't have to think like where it would run. You don't have to deploy a virtual machine. You don't have to deploy anything. You just say, this is my piece of code. I want it to run. And you pay for like the time it takes to run, essentially. And also it supports binding to cloud storage. So for example, you can say, I want a function that will run whenever I put a picture in the blob storage. And it would, for example, insert the date on top of the picture and put it in the other blob storage. And you can bind to the specific storage accounts declaratively. So you just say, I want the input of the function to come from here. I want output to go here. And then the function itself is just pure code which takes data and manipulates it. Very convenient way to build microservices applications without knowing the word microservices, without knowing the word Docker, Kubernetes, and so on. So that's and in our case, we will use Azure function to respond to REST call. So let's see how we create such a function. So first of all, I do func init coportrait. I create the function application, which can contain several functions inside. And I say Python because the Python is the language I want to use. And then inside this application, I create the function pdraw, which is based on HTTP trigger. So it would react to HTTP event. That's it. I have some files here, and I can start this function and see how it works. This function starts locally. This is happening locally, but using the function kind of architecture. So now once it's started, you can see it runs on localhost. I can go to the browser and call this function using the specified URL here. So to have this working, you need to install Azure Function like tools locally. It would install Node.js, and you need Python runtime if it's in Python. You can also use other languages for Azure Functions, by the way, like C# is even better supported than Python, I think. Yeah, now if I call the function, you see it returns me some kind of string. So where does this string come from? If I deploy the template is very simple. It's basically a hello world for functions. You have two important files. One of them is init.py, which contains the function main. This function main is the piece of code that runs when you call the function. It takes in HTTP request. And if you bind the function to some other properties in the cloud, like to the storage, it would also take the storage, the input parameters here. In my case, it's just HTTP request, and it returns HTTP response. And then I can do like I can extract parameters, and I can play with them, and I can produce HTTP response. So this is my code. And function JSON specifies bindings. Like in my case, I'm binding only input, like HTTP trigger is the input. You can see it supports get and post requests, and that's pretty much it. If I want to bind to some other place, I can add binding using this function JSON, or I can do it declaratively in the Azure portal as well. So how our blending function would work? It would work a lot with storage. In fact, I mentioned that Azure Functions can be bound to storage, and that's very easy. But in my case, I choose not to do the binding because I need to connect to 3 different blobs, and it's probably easier to do it from the code. So how to work with storage, you have the reference here in case you want to learn that. What I do here, first of all, I receive the image and I store it somewhere in the blob storage. I use clever naming because to retrieve last 20 images, they are retrieved alphabetically by name. So I need files to be sorted alphabetically in such a way that last files come first. So that's why I do stupid thing here, and I do the number of seconds till 1st of January of 2021, and that's why my program has the year 2021 problem. Yeah, that's the easiest thing I came up with. Then I do the image processing. I call the cognitive service. You see the detect with stream is similar function to what I have shown you earlier. And I do a fine transformation, and I store the manipulated, like rotated image into another blob storage. And finally, I take last 10 images here, and I blend them together. To blend images together in Python is a pure joy, because you just have the images and NumPy as NumPy multidimensional array, and you just call one function called average to create the blended version of all pictures. And to retrieve the 10 pictures, I use also very nice technology, because generators in Python, they are lazy, so I can use iSlice to just take the first 10 elements from the generator. So that's it. And then I store the result somewhere in the blob storage, which is public, and return the URL to it. So I return the URL, which is publicly accessible. So here you see my code in my local Visual Studio. It's the same code that I showed on the slides. I can then start the function locally. And you will see that it, in fact, works. We can debug everything here, because it's quite easy to debug locally because you see all the output. So here is the URL. I put in the input parameter, the image. And let me take again a photograph of myself. And I click send. And you can see in the other window that it does some output because it types something, the Python code, and we receive the URL. So if we open this URL, you will see the resulting picture. Yeah, that's the result of combining a few pictures together. Now we need to deploy this into the cloud. So to do that, we need to create the Azure Function in the cloud. We can do that either using the portal or CLI, then publish there, and then debug. So let's see how it works. So I will create the function application on the portal, because portal is probably the easiest thing to do. Because like if you don't know which commands to use, CLI is like for more experienced users, or if you want to create a repeatable process. Here in the function app, I put in the name. Then you can see I can use either Docker container or code, and I will say code, and I want to use Python. Then select the region, in my case, somewhere in Europe. And that's pretty much it. I can also select the plan type. It's either serverless or app service. App service lets you have the virtual machine all to yourself, in which case the function always runs very fast. If you do serverless, sometimes if the function has been idle for a long time, it would take at the first call some time to warm up. So, but then you pay as you go. So it's very convenient because you don't have to worry about scaling and all those things. So here is my function on the portal. You see that co-portrait is here, but it doesn't contain any actual functions. So to deploy my Python code, I go to the command line again. I say I want to publish this co-portrait function, and then it takes a long time because it's a little bit pre-recorded. I can go fast forward so that you don't have to wait and watch this. The important thing to note here is that when I was running function locally, I used my own Python environment. And when I deploy it, it would be running in the cloud in its own Python environment, which means that you need to be very careful putting in all the packages you need in requirements.txt. Otherwise, you would have errors which are not very well. They are not very easy to debug, not very difficult, but yeah, boring to debug, so to speak. So here is my function. Here you can see that from the portal you can monitor it, you can create the integrations and so on. And I can call it now from through the internet using this URL. You see the URL contains some kind of security code so that it's not publicly accessible by anyone. And it pretty much works the same as locally. I can put in the picture, I get in the URL. So that's it. Now I need to put it into my application, right? How do I do that? So inside here, I have the place when my picture is ready after I add it to the queue here. So I need to put in basically a call to this function. So how do I do that? I do call cognitive function and pass it the stream with the image, and then I insert the resulting URL into the interface using this result image.source. Call cognitive function is essentially one post call. You see post async. I call the function URL, I pass it the stream, and I get back the result as a string. Very simple. And just define the function URL here. That's it. I can now run it. And we will see how the complete exhibit works. First of all, it takes some time to run. You see now the function runs for the first time, and that's why there is a delay. That's why I am not very happy in this video. And yeah, you see, here is the result. And then again, and the next result arrives very fast. So if function is used like for more or less continuously, you don't have delays and it runs smoothly. Yeah, so that's the demonstration of the result. Now, this exhibit was in the museum for about a month before everything closed for the lockdown. And when it closed for the lockdown, I thought, like, how can we transform this experience into virtual experience so that people can enjoy it from home? And to do that, I decided to create a chatbot and then the web page. But the chatbot is even easier to create than a web page, so I started with a chatbot. So we have the chatbot here, or a web page through which you can do the same thing, and it would call the same Azure function and get the same result and show it to the user. So how do we create the chatbot? In Microsoft Cloud, it's pretty easy to do. You can go through the web portal. You say, I want to create web app bot. and it would create the bot. The bot uses so-called Microsoft Bot Framework, and Bot Framework is a really cool thing because it allows you to create a bot as a web service, which does request response type of work, and then you can bind it to some communication channels like Skype or Teams or Telegram and so on. When you write a bot, you can start with a template. So it's a good idea to start with the Echobot template. Echobot is the simplest possible bot, which just gives you back what you type. And then on this code, you can build any kind of functionality that you want. So if you start with this Echobot, you create it and it automatically does everything. Because for the bot, you need a few things like create an application and then bind the keys to the code and so on. All that is done for you. You just have the example code which works. And you can try to see it from the portal immediately. Like you can test the bot and web chat right here on the portal. And it will show you that the bot is functioning. And here it is. It just echoes back whatever you say. And then you just need to put in the logic to call the web service. So you go to this overview blade and download the bot source code from this portal. And then it downloads as the zip file. And then you open it in the Visual Studio to play with it. So I extract it to some directory. And I open it with Visual Studio. How the bot looks like. Bot is a web application, so it contains like controllers and everything. But the most important part is Echobot CS, which contains one function on message activity, which formulates the response. You can see that this logic which prints echo and then the text is contained right here in this function. So what we do, we replace those two lines of code by the code to call our Azure function. And that is pretty simple. I put the function URL here. And then the picture which the user attaches to the message is passed through attachments. So what I do here, I put a long piece of code, but it's pretty simple. I check the attachments. If the number of attachments is more than 0, I get the attachment using HTTP client, like I get the binary stream from the first attachment and pass it to my Azure function. And that's it. And then I return the result. I get the result as the URL, and I create the so-called hero card based on this URL. Very simple. Now to see how it works, I can run this bot locally. To run the bot locally, you need a thing called bot emulator. This is something you install. And then it allows you to chat with your bot, because even though your bot is a web application, it is a web API, so it's a REST application. It's not the website. And to chat with it, you use this bot framework emulator. You say open bot. You copy app ID and app password from appsettings.json. I want to show you a lot of things. That's why I go a little bit fast. And if you want to repeat this at home, you probably would spend a little time figuring this out. But essentially, you can see that it's not very difficult. So we open the bot. We paste here the app ID and app password. And connect. And now we can start chatting. If we say hello, it sees that there are no attachments, so it says please send picture. And if we send the picture as an attachment, it should give us back the result. And again, the first call to the Azure function takes a little bit of time. Here it is. So now, once I've done that, I need to deploy this code to the cloud, because right now I was testing the code locally. To deploy to the cloud, I can just do it from Visual Studio. I want to use existing app service. I select the app service name. And I skip a little bit here. So name, resource group, I select the right name for the bot, and I click deploy. And that's it. The code is deployed to the cloud. I can now go to the cloud and check if the bot has the new functionality. I can test it here in web chat. yeah, you see that my code is now running in the cloud, and I can play with it here. And the next thing I can do is to connect it to some kind of communication channel. So I always prefer to use Telegram because Telegram is the fastest to set up. And the way you do it, you go to channels here in the web interface in the Azure portal. And you say, I want to connect it to Telegram. Then we need to you can have all the instructions here if you want to learn how to do it. But essentially, what you need to do, you need to create the bot inside Telegram by chatting to a bot called BotFather. I will call it People Blender bot would be the name of the bot itself. And here you have the access token. You grab this access token, you put it into bot framework here in the Azure portal, and now your bot is connected to Telegram. Well, not now, in a few more seconds when it stops saving. I will skip that. So then you can go to Telegram, you can add this bot, and you can start chatting to it. So let me find it. Here, People Blender bot, and you can do the same if you have Telegram. By the way, you can look for People Blender bot. You can send it your picture, and it will give you back the blended version of your picture with some other people. So that's it. That's how easy it is to create the chatbot. So we have talked today about different technologies. So we mentioned how to create UWP applications. We talked about storage and using blob files from Python. We talked about Azure Functions, which are the great way to run any code in the cloud. We also talked about bot framework and cognitive services. And here you have the links to different technologies. If you want to dig a little bit more, you are more than welcome to do so. If you want to experiment a little bit more, you have the code that I have shown you available here. So the whole virtual exhibit code is on GitHub. And the code to draw virtual portrait itself, the cognitive portrait itself, is also on GitHub. So grab any of the URLs here and feel free to experiment and create something based on that. Tomorrow, as I mentioned, there would be a short masterclass specifically dedicated to creating your own portrait. So you can come there if you have any specific questions on the technique of drawing the portrait itself. And finally, I have one very simple call to action to you. If you can immediately after hearing my talk, go to this easyfi.net/peopleblend page. That is the web page, interactive web page, which will take your photograph through webcam and blend it together with other photographs of other people. So let's create the blended picture of all the conference visitors, of all you who are listening to my talk. And that's easy. Just go to this web page and allow it to access your web camera. Click take a picture and wait and observe the beautiful result. You can even do it a few times, and you can even share this link with your friends as well. So that's it for me. This process of creating this exhibit is also described in my blog. So if you prefer, instead of listening to me, to read boring text, then you can go and check here the same content in the textual form. Thank you so much for listening. I hope you enjoyed it, and I don't think we have a lot of time for questions, but we have the place to hang out after this talk. So if you go and join me there, I would be really glad to hear any feedback that you might have.